Google, IBM and Microsoft have all tried and failed, but Sydney scientists have finally done it.
Australia is taking a gamble on quantum computers by investing up to $1 billion in a Silicon Valley startup.
15 world-class scientists woke up one morning to find their cutting-edge research facility shut down without warning. No countdown, no discussion. The Australian government, they found out through the news. Microsoft didn't even call. But just months after this devastating closure, Microsoft dropped a bombshell that sent shockwaves through every tech giant and government on Earth. They claimed they'd achieved the impossible. Was this shutdown a devastating failure, or the most calculated power move in tech history? Let's find out. The shocking announcement. Imagine you're one of the world's brightest quantum scientists working on technology that sounds like pure science fiction. You wake up one morning, grab your coffee, and suddenly discover your entire research facility is being shut down. Not in 6 months. Not next year. Right now. That's exactly what happened to Microsoft's quantum research team in Australia back in July 2024. 15 brilliant researchers at the University of Sydney got the news that would change everything. Their state-of-the-art quantum lab, housed in a stunning $150 million Sydney Nanoscience Hub, was being closed down faster than you could say quantum entanglement. But here's where it gets really juicy. The Australian government? They had no clue this was coming. Zero, nada, zilch. Government officials were kept completely in the dark about Microsoft's plans until after the company had already made generous offers to relocate the entire team to their US headquarters. Talk about awkward timing. The Australian government had just invested hundreds of millions of dollars and spent massive political capital promoting Australia's quantum research capabilities.
The Australian government is investing millions in growing the quantum industry. So much of what we do relies on computers. Even simple tasks require a lot of processing power.
Imagine bragging about your country's quantum prowess one day, only to wake up the next morning and find out that one of your biggest tech partners just packed up and left without even a heads-up text message. The partnership between Microsoft and the University of Sydney was supposed to be a game-changer. The facility was the latest, the scientists were world-class, and the potential seemed limitless. So what went wrong? Why would Microsoft suddenly abandon what seemed like a promising venture? The official explanation was that they wanted to consolidate quantum efforts at their Redmond headquarters in the US. But is that the whole story? The plot twist. Microsoft has spent years and billions chasing quantum supremacy, but instead of following Google and IBM's path, they bet everything on a risky idea: topological quantum computing. While others used fragile qubits prone to errors, Microsoft pursued topological qubits, qubits that could shield themselves from instability. The key to this approach was the Majorana fermion, a particle so rare it's called the unicorn of quantum mechanics. Their Australian lab became ground zero in the hunt. But as years passed, doubts grew over whether the gamble would ever pay off. But wait, here's where this story takes a completely unexpected turn. Just when everyone thought Microsoft was giving up on quantum computing, they dropped a bombshell that sent shockwaves through the entire tech industry. In February 2025, the impossible happened. Microsoft unveiled Majorana 1, the world's first quantum processor built on topological qubits. They introduced a new class of materials, topoconductors, capable of controlling qubits using topological superconductivity. It represented an entirely new foundation for quantum computing, pushing the boundaries of what scientists thought was possible. The timing raised eyebrows. Microsoft had shut down its Australian lab in mid-2024, only to announce a historic breakthrough months later. Some believe this wasn't failure but strategy, consolidating resources to accelerate progress. Whether it was calculated foresight or a stroke of luck, the result is the same: Microsoft may have just shifted the entire quantum race in their favor. The question now is whether this gamble makes them the undisputed leader, or if it's still too early to declare victory. The quantum arms race and the secrets. The race for quantum supremacy is heating up, and Microsoft isn't running alone. Countries and companies alike are pouring billions into quantum research, creating what many experts call a quantum arms race. China has made quantum computing a national priority, investing heavily in recruiting top talent, while US tech giants like Google and IBM push forward with their own approaches. Even startups like IonQ and Rigetti are gaining traction. In this environment, Microsoft's decisions are about survival in a global race where second place may not matter. Microsoft shut down its Australian lab to consolidate power. Instead of scattering talent across continents, they brought their team under one roof, maximizing collaboration and speed. In a field with so few true experts worldwide, centralizing talent isn't just a business move, it's a defensive strategy. By relocating their Australian researchers, Microsoft ensured their hard-earned knowledge stayed intact and focused on one ambitious goal, on building a topological quantum computer. But here's where things get interesting. Microsoft has always been vocal about the promise of their topological approach while staying oddly quiet about its difficulties. Creating stable, working topological qubits is incredibly hard. And while rivals have delivered functioning quantum machines, Microsoft's breakthroughs remained more theoretical. The closure of the Australian lab sparked speculations. Was it a retreat, a restructuring, or a sign that Microsoft was closer to success than anyone realized? That mystery is part of what makes this story so compelling. Insiders whisper about setbacks, breakthroughs, and secret discoveries, but Microsoft reveals only what it wants the world to see. Some believe they hit a roadblock. Others think they uncovered something worth guarding at all costs. The truth may lie somewhere in between, but one thing is clear. Microsoft's silence is strategic, and in a race this high stakes, what they're not saying might be just as important as what they are. The breakthrough and what it's bringing for the future. In February 2025, Microsoft unveiled the Majorana 1 processor, a breakthrough that could mark the beginning of a new quantum era. This chip reportedly achieves something long thought impossible: the creation and control of Majorana fermions inside a quantum computer. It's the culmination of years of risky bets and strategic moves. Still, doubts remain. Microsoft has a history of bold claims that didn't fully deliver, and the quantum field itself is full of hype and setbacks. The big question is whether Majorana 1 can actually outperform other quantum systems, or if it's another overpromised milestone. Adding to the intrigue is Microsoft's decision to shut down its Australian quantum lab, which once looked like retreat, but now seems like strategy. By consolidating talent and resources, they may have positioned themselves for this very breakthrough. The move raises larger questions about secrecy in science and business. When should companies be transparent, and when should they guard discoveries to stay ahead? In this case, Microsoft seems to have kept its cards hidden until it believed history was ready to unfold. So, why should any of us care? Because this isn't just another tech upgrade. Quantum computing could be the biggest leap forward since the birth of modern computing itself. We're talking about solving problems that would take today's supercomputers millions of years. Imagine designing life-saving drugs in days, predicting financial crashes before they happen, or powering AI systems that make today's ChatGPT feel primitive. That's the promise, and Microsoft is betting their future on it. But there's also a darker undertone. Whoever cracks practical quantum computing first gains massive leverage in cybersecurity, artificial intelligence, and global economics. Microsoft's move to bring everything back to the US was about geopolitics, about keeping groundbreaking technology on home turf in an age where technological nationalism is stronger than ever. In other words, Majorana 1 isn't just a scientific milestone. It's a statement in a global race where the stakes couldn't be higher. The rumors and its global implications. Rumors surrounding Microsoft's quantum ambitions paint a picture of high-stakes pressure and internal debate. For years, the company has championed its topological quantum computing approach. But behind closed doors, some researchers questioned whether it was the right bet. The closure of their Australian lab may have been less about logistics and more about consolidating focus, with Microsoft doubling down on its original vision rather than diversifying into safer, conventional methods. Another layer to the story involves the fierce competition for talent in quantum research. These scientists are some of the most valuable professionals in the world right now, with companies offering extraordinary pay to recruit them. By relocating their Australian team to the US, Microsoft not only kept its top researchers close, but also prevented rivals from poaching them. In a field where human expertise is as critical as hardware, securing the right people is half the battle. Adding to the intrigue are whispers that Microsoft may have made a critical breakthrough with Majorana particles earlier than publicly acknowledged. If true, this would explain their confidence in reorganizing their operations so dramatically. Some insiders even suggest that these advancements could feed into larger, as yet unannounced initiatives, perhaps quantum-powered AI, enhanced cloud systems, or even technologies that could redefine entire industries. The secrecy surrounding these efforts only fuels speculation. Quantum computing could upend encryption, medicine, finance, and artificial intelligence, giving whoever masters it first an extraordinary advantage. That's why nations like China, the EU, and others are racing to lead in this field. Microsoft's choice to centralize operations in the US is both a business decision and a geopolitical one, signaling a shift toward what some are calling quantum nationalism, where collaboration takes a back seat to securing dominance in one of the most important technologies of the century. Technical challenges and the human cost of quantum innovation. Quantum computing is notoriously difficult, and Microsoft's approach has been especially controversial. Traditional qubits are fragile, requiring extreme conditions to function, colder than outer space, shielded from vibrations, and isolated from interference, yet they still lose stability in microseconds. Microsoft bet on a different path: topological quantum computing, which uses exotic particles called Majorana fermions to create qubits that are naturally stable and resistant to errors. In theory, this could eliminate many of the problems plaguing other quantum systems. The challenge, though, is that Majorana fermions are incredibly elusive. They exist only in rare conditions and for fleeting moments, making them nearly impossible to control. For years, Microsoft's researchers chase these particles, producing hints of progress, but also setbacks and skepticism. Some in the scientific community even questioned whether the pursuit was realistic or just a corporate fantasy. The Australian lab became the heart of this effort, working on exotic materials and control systems to turn theory into reality. Then, in 2025, Microsoft announced Majorana 1, claiming they had finally achieved stable topological qubits and performed quantum operations once thought impossible. If true, it could represent one of the biggest breakthroughs in computing history. Still, independent verification and practical results will determine whether Majorana 1 is a genuine leap forward or another overhyped milestone in the long, uncertain road of quantum innovation. But behind the science lies a human story. The closure of the Australian lab disrupted the lives of brilliant researchers who had moved across the world to work on Microsoft's vision. Some relocated again to the US. Others stayed in Australia, and a few were snapped up by rivals. For families, it meant uprooting children and lives built around the lab. For those who stayed with Microsoft, however, it could be the chance of a lifetime, helping shape a breakthrough that could define the future of technology. And as researchers reshuffled, the ripple effects spread through the entire quantum community, reshaping collaborations, competition, and the global race toward quantum supremacy. Effects across tech industry. Behind the polished press releases, Microsoft's quantum journey is stirring both excitement and doubt within the research community. Publicly, the company highlights breakthroughs with Majorana 1 and its vision for topological quantum computing. Privately, however, experts admit the situation is far more nuanced, with some cautiously optimistic while others remain skeptical until independent verification and real-world demonstrations prove the claims. Supporters believe Microsoft could indeed be on the verge of stabilizing topological qubits, a move that would revolutionize the industry. Yet critics point out the long history of overhyped quantum announcements that fizzled out. Adding to the complexity, the closure of Microsoft's Australian lab has fueled debate about whether international collaboration in quantum research is being replaced by a more nationalistic and secretive approach, potentially slowing scientific progress. At the same time, some see this competition as a necessary driver for innovation. With billions at stake, companies and governments are investing heavily, hoping the pressure will accelerate breakthroughs faster than open collaboration alone could. Microsoft's broader strategy of tying quantum research to Azure cloud services and partnering with hardware firms signals that it's preparing for a future where quantum computing goes commercial, not just experimental. The ripple effects of this shift extend far beyond Microsoft. Quantum and AI are converging, with each field enhancing the other, while cloud-based access promises to democratize quantum computing for researchers and businesses alike. But concerns remain. From the risks of one company holding too much control, to the global talent war draining universities, to governments tying quantum advances to national security. Microsoft's drama is just one piece of a much larger transformation that could redefine technology and power in the decades ahead. Hype or the dawn of new era? Quantum computing operates on principles that stretch the limits of human understanding, and Microsoft's recent work has pushed the field into even stranger territory. At the center of their approach are Majorana fermions, exotic particles that are their own antiparticles. Unlike traditional qubits, which are highly fragile, qubits made from Majorana fermions distribute quantum information in a way that makes them far more resistant to errors. This property could solve one of the biggest challenges in building reliable quantum computers. To put it simply, while traditional qubits are like writing with pencil that can be smudged or erased by the slightest disturbance, Majorana-based qubits are more like carving information into stone. This durability has fueled Microsoft's development of topoconductors, a new class of materials that could extend beyond quantum computing into fields like energy storage and advanced electronics. If proven, these materials would not only accelerate the path to quantum breakthroughs, but also transform how we build and power technology. The potential impact goes even deeper. Microsoft claims its Majorana 1 achievement bridges the gap between abstract physics theory and real-world application, turning particles once confined to textbooks into functional technology validates some of the strangest predictions of quantum mechanics. Still, the story carries risk. Microsoft's closure of its Australian quantum lab initially appeared as a setback, but might have paved the way for this breakthrough. If Majorana 1 lives up to its promise, it could spark massive shifts in investment, competition, and government funding across the industry. If it falls short, however, Microsoft could face criticism for retreating from international research only to deliver disappointing results. Either way, this saga highlights the unpredictable path of technological progress. Sometimes a retreat is only the setup for a leap that could redefine the future. Microsoft's unexpected closure of its Australian quantum lab was a calculated gamble on topological quantum computing that may have sparked a historic breakthrough. After years of delays, doubts, and tough choices, Microsoft now stands at the edge of reshaping the future of technology with its Majorana 1 project. Whether it delivers on its bold promises remains to be seen, but one thing is certain: the quantum race just changed overnight. What do you think? Was this a genius move or a risky gamble? Let me know in the comments.